Hi students, let us learn about EMF and internal resistance of a cell. Hope all of you know about cells. These are cells. This is the symbol used to represent a cell. This is the positive terminal of the cell and this is the negative terminal of the cell. A constant potential difference is maintained between the two electrodes or the terminals. In a cell, the chemical energy is being converted into electrical energy. An electric cell is a device in which a constant difference in potential is maintained. That means the potential difference is constant between the two electrodes or the terminals. This electrolytic cell will maintain a steady current in an electric circuit. It consists of two electrodes, a positive electrode and a negative electrode. The positive electrode is known as anode and the negative electrode is known as cathode. These electrodes are dipped in an electrolytic solution. This is the electrolytic solution and these electrodes are dipped in that electrolytic solution. Free ions will be present in this electrolyte so that it can conduct electricity. Electrodes are the conductors through which current can pass. This is the external part and this is the internal part. We know that the electric current flows from the positive terminal to the negative terminal. That is the conventional current flow. The electrons are flowing in the opposite way. That is from the negative terminal to the positive terminal or the electrode. That is in the external part, the electron flow is from the negative terminal to the positive terminal when you consider the external part. If you consider the internal part, it is from the anode to the cathode. The electrons are flowing from anode to cathode. As there is a potential difference between these electrodes, charges will flow. You can create a path by connecting a conducting wire. This electrolyte will provide the medium for the exchange of electrons between the cathode and the anode. This simple device maintains a steady current in an electric circuit. Basically, it has two electrodes. One is positive and the other is negative. This is the positive electrode and this is the negative electrode and they are dipped in the electrolytic solution. And dipped in the solution, these electrodes will exchange charges with the electrolyte. Chemical energy in the cell is being converted into electrical energy. What do you mean by electromotive force of a cell or EMF? Electromotive force is otherwise known as EMF. What is that? It is represented by the Greek letter epsilon. Epsilon. Actually, this is a characteristic of a cell. When you hear this term electromotive force, you will think it is a force, but it is not a force. It is actually potential difference. EMF is the potential difference when no current is drawn from the cell. That means when the cell is in an open circuit, you will use the term EMF. The potential difference between these two electrodes is called as electromotive force. This is positive and this is negative. Let V plus be the potential of the positive electrode or the anode and V minus is the potential of the negative electrode or the cathode. The difference between these two will be P plus minus. This negative electrode is already negative. Therefore, you must put negative. One is positive and one is negative. This is the difference. Therefore, this minus and this minus will become plus. You can write V plus plus V minus. This is called epsilon or EMF. Anode has a positive potential V plus, whereas cathode has a negative potential V minus minus V minus. This potential difference is equal to V plus minus minus V minus. Epsilon is equal to V plus, this minus and minus is going to plus, therefore V plus plus V minus, and this is a potential difference, therefore the unit is volt. What do you mean by terminal voltage or potential difference of a cell? It is represented using the letter V. Earlier we have seen electromotive force. Electromotive force or EMF is the potential difference when the cell is in open circuit. When the cell is in closed circuit, you will get the terminal potential difference or terminal voltage. You consider a resistor is connected across the cell. Anode is positive and cathode is negative. The conventional current flow is from the positive to negative. Inside the electrolyte, the current flows from N to P, whereas it flows from P to N in the external resistor R. The voltage across this external resistor is called as the terminal voltage or the potential difference. E is equal to IR if I is the current flowing in the circuit. When current is drawn from a cell, that is when the cell is in closed circuit, the potential difference between the electrodes of the cell is called its terminal voltage. Now you can see a 10 volt cell which is being connected to a 1 ohm resistor. This is called load. The circuit is closed. The potential difference across this resistor is known as terminal voltage. V is equal to I into R, that is the terminal voltage or the potential difference. Now let us learn another term which is called internal resistance of a cell. Internal resistance of a cell is represented by small letter R. This is the diagram which we learned in our previous slide, where a resistor is connected in the external circuit. We understood that the electric current flows from the positive terminal to the negative terminal, and inside the electrolyte it goes in this way. Therefore, the circuit is complete. The resistance offered by this electrolyte is known as internal resistance. This internal resistance is very small. A cell will be always having an internal resistance. This is the cell where internal resistance is shown. This is the internal resistance. This is the external resistor. The external resistor which you connect. The electric current starts flowing from the positive terminal to the negative terminal of the cell. The terminal voltage or the potential difference across the external resistance is V is equal to I into R. When the electrons flow inside the electrolyte will offer some resistance which is called internal resistance. Let V be the small letter v. Small v is the voltage drop across this internal resistance. Therefore, small v is equal to IR. Small r represents the internal resistance. This is called voltage drop. What is epsilon? Epsilon is the electromotive force, that is V plus small v, where V is the terminal voltage and this V is the voltage drop. Therefore, V is equal to epsilon minus small v. Therefore, capital V, or the potential difference, is equal to epsilon minus IR. We know small v is voltage drop, that is IR, and R is the internal resistance. This epsilon is always greater than IR. Mostly we neglect this internal resistance as this resistance is very small. The resistance offered by the electrolyte inside the cell to the flow of current is called internal resistance. As this is the resistance, the unit is ohm. We learn terminal voltage V is equal to IR. Here in the internal resistance, we learn voltage drop is equal to IR. That is the voltage which is dropped in the electrolyte. Let us now look into the expression for current in a cell. We know the potential V is equal to epsilon minus IR, because epsilon is equal to capital V plus small v, where small v represents the voltage drop due to this internal resistance and capital V represents the voltage drop due to this capital R. The small v we learned as I into small r. Therefore, V is equal to epsilon minus IR. From Ohm's law, capital V is equal to I into capital R. Therefore, IR is equal to epsilon minus IR. Take this IR to this side. Then IR plus IR is equal to epsilon. This negative sign, when it goes to this side, it will become positive. I and I is common, therefore take I outside. I into R plus R is equal to epsilon. Therefore, I is equal to epsilon by R plus R. In this session, we learned about electromotive force of a cell or EMF of a cell. EMF of a cell is represented using the letter epsilon, and it is the potential difference when the cell is in open circuit. And terminal voltage or the potential difference is represented using the letter V, and V is equal to I into R. This is the potential difference when the cell is in the closed circuit. And what do you mean by internal resistance of a cell? Every cell will be having a small resistance of its own, and that is the resistance which is offered by the electrolyte. Finally, we learned about the expression for current. Expression for current I is equal to epsilon by R plus R. Hope you understood this session. See you in the next class.